This video will introduce you to your Kodu challenge. Your challenge is to create a two-player football game. We can see here football obviously involves some players hitting a ball around the field and trying to get them into the back of the net. We're using an abstraction in terms of object-oriented programming here. Recall that an abstraction is where you take a real-world example. So here we have a football player celebrating, and you then turn it into a class, which is a kind of blueprint for how to make examples of the real-world item. Footballers will have statistics about their abilities, which teams they play for, and so on. And these are collected together as part of the properties of the class. We would also have information about how the players look, and we can see that a mesh, a 3D mesh, would be used to represent a player. And they would also have abilities, which would have animations to show up on the screen. So here we can see a player dribbling. The class is a description of how an object is created, and the object itself is an example of the class that runs in the computer's RAM and is able to be shown in the game. So here we can see a game version of a player performing a goal celebration. Another important issue in object-oriented programming is inheritance. Inheritance means specializing of a base class. For example, we could make a player class which would look like a human being, and this would allow us to have various pieces of information such as the height of the player, what speed they can run at, their hair color, what the color of the strip is, and so on. They would also have some standard methods. These are the abilities that the player has, such as running or standing idle. We could then take this player class and specialize it into a footballer who would have additional abilities to kick a ball and to head the ball, or to a cricketer who would have the ability to use a bat to hit the ball and defend their stumps. We can take this idea of inheritance further. So once we have a soccer player or footballer, we can then specialize this into strikers, defenders, and goalkeepers. Just as the football players had extra abilities to kick the ball and head the ball, so the goalkeeper would have additional abilities to use their hands to be able to handle the ball. We might even create special goal celebration abilities for our football player. The goalkeeper clearly has to have additional abilities and also the animations that go with that. We might not necessarily think to include every possible animation, such as a double-footed back kick to save a goal. Another possible example of abstraction is to take a real-world object, such as a table football table, also called a foosball table in the continent and America. So we take this real-world version of a game, we create a class from it, and the class is a description of how the game will work. How many rows does it have? How many players on each row? What colors will the players have on the different rows? And we use this information to create a blueprint, that is, a template or set of instructions for how the game operates. Once we have our class created, we can then create in RAM an actual example of the game, and this could then be played as a game for players. Your challenge is to create one of these two types of games. You could create a simple football game with two players, and they have to hit the ball into each other's goals to score points. Alternatively, as a more challenging game, you could try to create foosball, where rows of players can move in time with each other to defend and attack the other player's goal. I'm going to show you now how to get started with drawing the football pitch and a little bit of coding, and the rest of that is then up to you to complete for your coding challenge. Before you start, you should have a think about some ideas that will affect the gameplay. For example, the ball. How bouncy should the ball be to give an effective game? You may have to experiment with the bounciness of the ball to see what works best. When the ball goes into a goal, if you have a hole for that, should the ball then be reset, a centre kick to restart the game? Are you going to have a hole that you kick the ball through, or are you just going to bounce the ball off of a solid wall to score points? How are you going to know which side has scored? Are you going to look at the ball getting onto a different coloured land, or are you going to use some other mechanism for deciding who has scored? Will the players nudge the ball along, dribbling, or will they kick the ball by launching it so that it goes far and fast when they touch it? And if you're making a foosball version, how will you get them to move all at the same time? Do they move forward and backwards, or only left and right? So think about these ideas before you start to code. Now, to create the pitch, we're going to use a few specialist tools in terms of drawing and also raising the walls. So we're going to use a straight line brush to draw the edges, and then we're going to use the magic wand brush to raise these areas. I'm going to demonstrate that now.